Good afternoon. Welcome to the Embedded Executive Podcast. My name is Rich Nass. I am the Executive Vice President of Open Systems Media, and I lead the content team for Embedded Computing Design. This week, my guest is Michael Baska, the Vice President of Embedded Products and Systems from Micron. How you doing, Michael?
I'm doing great, Rich. Looking forward to a good conversation.
Okay, well, hopefully we can fulfill that goal. We'll see what happens.
Exactly. Let's do it.
What I wanted to talk to you about is something, we obviously had a short conversation a little while ago, and I always come back with it's just memory. And I say that to all the memory guys, and I insult them, piss them off, and they say, no, that's not the case. So I want to talk about how you differentiate for different segments. So the one that hit home was automotive. What's different about memory that's designed specifically for automotive? And do you guys say, hey, we're putting this memory in a car, so we have to design it differently than this memory that we're putting in a data center or in a smartphone or something else?
Yeah, absolutely. So, a couple things. First, just the sheer size of the business, the amount, the dollar value, if you will, of the memory and storage that are going into vehicles has become quite significant. And so it's just top of mind for just even from the dollar perspective and the impact that it has. But far beyond just the dollar value, right? The features that the memory has are a key experience around both the in-cabin experience that we all have as drivers and as passengers, but also the increasingly autonomous nature of the driving experience as well. And so these are key factors. And as you might mention, as soon as I say autonomous driving, right, there's a lot of safety implications that I think we all can come to mind for that. So we absolutely design our product, manufacture our product uniquely for automotive to meet some of those kinds of needs.
So what I'm hearing, though, is that when I said automotive, you actually slice it much thinner than just automotive. Something that's under the hood is designed differently than something that's in the cabin. Is that what you said?
Well, from an overall automotive quality, they both have similar needs. But in terms of the adoption of how they go into a system and what that system is doing, you're correct. So, all of them we do, for example, automotive temperature grade are typically required for all of the, whether it's in cabin or under the hood. Automotive temperature is needed. The robustness of shock and vibration, from a packaging experience, those are also similar. So there are some OEMs out there that are starting to, revisit some of those older paradigms, but those are very early and just in exploration. So at this time, kind of across the board, it's all, are still our traditional automotive requirements in that space.
Does it have to do a lot with how you test them? Okay, we're going to take these. If these don't fail at this temperature, then we'll use them for under the hood. But we're only going to test these up to this temperature. Or am I oversimplifying it?
Yeah, so testing is an element, but it's really the last thing that's done. You can only test in so much quality, so it is an important part to make sure our test coverage is there. Both the temperature range, but also just the robustness of the algorithms that go test all the corners, that you might encounter. But it really starts all the way upstream. And this is where, for example, some of the failure rates as system designers are trying to, hit certain failure in time, certain fit rates out in the field. Automotive is an extremely challenging usage model. Having these devices at elevated temperatures, much hotter than, say, a mobile phone in your hand would be, or a laptop or PC on your desk would be. So, and then the data retention requirements for a lot of the storage are also very challenging, where in part because of this extreme temperature. So, for example, you might get an over-the-air update for the vehicle while it's been running for a while. It's a hot environment. And then someone might park it at an airport for a while and then come back from a flight and need to start their vehicle in a very cold environment where it's, maybe Chicago in the winter. So again, these are things that you have to really do from the initial design in stage, and as well as the process definition. And then, yes, it's in the end, the test is also a key part of that.
Okay. So I'm gonna go in a direction now that you're not prepared for, so I'll apologize in advance if you don't know where I'm going. We've been talking a lot about how we divide up the car, and there seems to be this pendulum that's going back and forth between should we have one central compute point or should we have smaller compute points all around the car? Do you care as a memory guy if there's one central point in the middle that's doing all the computing, or each function has its own subsystem?
Well, so yeah, we're today we service both of those models because there are still some older architectures that are in that more distributed model. We do see centralized compute type of architectures coming online today. From our perspective, certainly both can be serviced. There are some advantages into the centralized architecture, such as the sheer size of memory pooling, if you will, and storage pooling, where you have multiple devices spread out all over the vehicle. Often each one will only need a very small amount of memory and storage, and that can get inefficient for the latest and greatest process technologies, right? When we make these huge investments in our factory and bring out our newest manufacturing process nodes, there's kind of a minimum density size that makes sense to have from a design perspective to hit certain geometries of the die size. If you try to shrink it beyond that, you basically just bond pad limited and you're not getting much die size savings. And so, hitting some of these higher density points on both of them has advantages, both for us as a memory storage supplier, but also for, the tier ones and the OEMs actually making the vehicles, being able to get a little total cost of a better total cost of ownership.
So I happen to be more of a proponent of the distributed model, and I'm not offended that you called me antiquated. I know you weren't referring to me. I want to just replace a subsystem when I can. If I want to upgrade, or if the vehicle is in an accident or damaged, I don't want to replace the whole computer, which might run into the thousands of dollars. I just want to replace my one subsystem. No, you don't think that's where we're going?
It's a great point, Rich. I would want the same thing for sure, and I'm sure I would expect many of the listeners do as well. So you bring up a good point, which is, it is still possible in this centralized compute to design it, in a way where it's still modular at some level. And so, we see, for example, migration towards some of these centralized domains. So you might have an IVI module or a card slot that goes in. You might have a IVI is the in-vehicle, right, which is mostly the in-cabin experience on the center console. You might have one for ADAS and telemetry. So you do bring up a good point, which is I think you're still going to see some of this modularity in the chassis of the centralized vehicle to be able to do some of this replacement. And it is something that certainly we have in discussions with OEMs and tier ones. This serviceability is definitely something that's top of mind in that space.
Okay. So what is it that the auto OEMs are asking you for next? What's the hard part from your perspective? They always ask for more than you can actually deliver. So what is it that they want from you guys?
Yeah, there's a lot of key things that are coming into this space around that are driving needs for performance bandwidth for both memory and for storage beyond what we've seen in the past. And just to give you a flavor for, right, the pretty exciting things that are driving that. So one is, Gen AI capabilities inside the vehicle. So this is something there's already a lot of momentum in both the PC space as well as the mobile space for that experience to be coming in the not too distant future, right? Potentially by the end of the year, or certainly in the early part of next year. I think we'll see some excitement around there. And as OEMs and vehicle makers are looking at the cabin experience, I think all of us as users are going to want similar. And so the performance that you want to be able to do, again, with a vehicle, you may have some additional challenges where you could be in a remote area, some of the connectivity challenges you could have, and certainly you don't want that latency. And so they want to provide this capability locally in the vehicle. So this is driving very high performance requirements on the DRAM, very high performance requirements on the storage to be able to download these LLMs and LVMs out of the storage because they're likely to have to run, 3, 4, 5 different applications or LLMs in a short period of time. And so the time to get that out of the storage and into the DRAM to be able to execute and have it respond to the user needs to be well less than a second. So these performance bandwidths are key, and this is where a lot of our high performance DRAM with LP5, LP6, and on the storage side we have our centralized storage of 4150 AT that we recently announced, as well as high performance UFS coming with Gen 4 and eventually Gen 5 that's going to be able to deliver some of those things.
Okay, one more question, then I'll stop badgering you. When it comes to these interfaces and with the memory, everybody wants everything to be standardized. But are the automakers moving too fast, and is the technology moving too fast to have this be standardized? Because the standardization process is often a long, arduous one. Do we need to wait for the standards to be in place, or do we just go?
Well, so we do have some standards that are being some relatively new standards that are just getting into the implementation stage in this space. So in a couple examples are the functional safety specification, which is the 26262 from ISO. You also have cybersecurity, which is 21434. So there are some standards that are already in place that are actually in the adoption stage. And as we're coming out with memory and storage products conforming to these, we are seeing significant adoption and interest for customers to be able to utilize those, at the leading edge of the market. So I think in that space, the standards are actually well positioned to cover some of those needs, at least for the next several years. I'm sure there'll be some needs that will evolve beyond that. We'll need to continue to stay nimble as an industry with some of those specifications in that.
Okay. This must be a boon to the memory guys. I mean, there's so much memory in these cars. If you just go back 10 years, it's probably an order of magnitude difference.
Yeah, the growth rates are certainly so among the highest across all of the applications where memory and storage go. Now, the size of the market, is still significantly smaller, right? The memory and storage are still, from an overall TAM perspective, dominated by the mobile phones, by the data center, and by PCs. And so that still drives from a just an economic cost benefit. A lot of the investment is targeted for products that are those. But whereas you used to see automotive on the lagging edge of those technologies, it's now using those products, as soon as they're available in those other applications, the mobile phones and PCs and so forth. We're seeing them go into automotive. A couple examples, today we have already our LP5, LP5X out to automotive customers, not just sampling development, but actually out on the road. And similarly, we have some of our 176 layer based NAND storage devices in UFS and eMMC, as well as PCIe based interfaces. And so it's a very exciting time, trying to stay up to the latest and greatest product technologies, and working with OEM vendors on how can we deliver those specifically for the automotive with some of the specialized needs that we talked earlier.
Is there ever a crossover where the automotive market is bigger than the smartphone market in your projections?
We don't see that today, but we do see some of the technology requirements potentially surpassing some of those other applications. And we'll see. It's still speculative. Some of the things that I mentioned with the in-cabin experience on Gen AI, again, depending on some of the visual aspects and video based, in addition to the language that you might have in the vehicle. So today there's already cameras that monitor gestures and making sure that you're awake and not falling asleep, and those can easily then be you could see where those might be then developed into Gen AI type of applications. And so again, this is where I think some of the products that we see, we have customers, for example, who are interested in high bandwidth memory, HBM, which is primarily a data center application, are interested in that kind of technology for the vehicle, which is unlikely to make it into a phone anytime in the near future. So again, from a technology perspective, we are seeing some of those needs outstrip some of the other traditional applications.
Well, lots of people liken the car to just a Smartphone on wheels.
Yes, yeah, smartphone. So there are certainly parallels that we see. The in-cabin experience does have a lot of parallels with the mobile phone experience, right? A lot of it's entertainment, right? It's seeing the maps, it's seeing videos, it's interacting with this, live assistant, which again are things on your phone. Whereas the ADAS, a lot of that driving, the algorithms that run, there's the training, there's the inference, in a lot of ways are like a data center type of application. And so to some extent in the vehicle, you're really getting a blending of those two. And when we talked earlier about some of the domains may stay separate, yeah, we'll see how that evolves. And that's a possibility where you could, to some extent, have both of those coexisting simultaneously within the vehicle.
Good stuff. Looking forward to it, Michael.
All right. Thanks, listeners. And thanks, Rich. Really enjoyed it.
That was Michael Baska. He is the Vice President of Embedded Products and Solutions and Systems for Micron. And I'm Rich Nass with Open Systems Media.